In this problem, in the figure, there are 2 point charges plus q and minus q inside the cavity of a spherical shell. The charges are kept near the surface of the cavity on opposite sides of the center of the shell. If sigma 1 is the surface charge on the inner surface and q1 net charge on it, and sigma 2 the surface charge on the outer surface and q2 net charge in it, then which of the options are correct? That is the problem given in 2015. Let us solve. Here when you see inside the cavity the net charge, let us calculate net charge inside the cavity. Small q is equal to plus q is there and minus q is also there, so net charge is equal to 0. On the surface the net charge is q1 given. In the problem it was mentioned the net charge on the outer surface is q2. So the net charge q1 became 0. Therefore that implies q1 is equal to 0. But one thing we have to remember, when the charge is there plus q, here the opposite charges will be induced on the surface of the cavity. Inside the cavity this side negative charge is there, so positive charge obviously induce on the surface of cavity. So here in the problem they have mentioned about the surface charge density sigma 1 on the inner surface of the cavity. So on the inner surface of the cavity, even though the charge became 0, here the charge on the surface is still there. So on the surface charge is spreaded means surface charge density is there as induced charges are present on the inner surface of the cavity, right? What happens? The surface charge density is not equal to 0, and the surface charge density is not uniform, it is varying. Surface charge value is varying, so it is not constant and it is not equal to 0. But here the net charge on the inner surface q1 is equal to 0. Here the net charge became 0, still it possesses the surface charge. As the charge q1 is equal to 0, no induced charges will be there on the outer surface. As q1 is equal to 0, that means q2 is also equal to 0. That implies sigma 2 charge density on the surface of the outer surface of the cavity is also 0. So this is the consequence of presence of two point charges inside the cavity. So let us write the results in a way. The q1 is equal to 0, but sigma 1 is not equal to 0, right? Second inference we got is q2 is equal to 0 and sigma 2 is also equal to 0. So this is the correct inference. Let us see which option is correct according to this one. So sigma 1 is not equal to 0. Yes, option B is the correct option. In this problem, charge is distributed within a sphere of radius r with volume charge density. So he is mentioning volume charge density means it is a non-conducting sphere. The density, which is the function of r is the distance from the center of the sphere. This is the meaning of this one. So rho r is equal to a by r square into e power minus 2r by a, where a and small a are constants. If q is the total charge on this charge distribution, the radius r of the sphere we have to calculate. So according to the problem, a non-conducting sphere is there. This non-conducting sphere radius is r. This is the center of the sphere. So total the sphere is charge is there. So to calculate, let us take a small element like this, which is having the radius smaller. Why? Because with this distance the density of charge changes. Yes, see, inside charge is less, and if you go away from the center, more charge will be there. So the thickness of this elementary sphere we have consider. Let the thickness is dr. Like this we have selected. So all over this charges are there. So charges are there all over. So whenever the charge density increases, the electric field also, the magnitude of electric field also increases. So from the center, if you go away from the center, this charge density goes on increases, and electric field also goes on increases. Anyhow, we know that in a non-conducting sphere, this electric field is linearly changes from center to surface. After that, it exponentially decreases. Anyhow, let us. So we have taken a small element. So what is the charge on small element? Let us calculate. Therefore, charge on small elementary spherical shell dq is equal to, see, this density of charge is changing with distance into volume. So this is the formula for charge. But we have taken a shell. So what is the volume? The shell is having surface area and the thickness. So like this we can take a formula. Let us substitute the values here. So dq is equal to, I will write here, dq is equal to rho r, the function of r, dA, the area. So surface area of this shell is 4 pi small r square into dr. So this is dq. So let us calculate that. Therefore, the net charge on the sphere, total sphere, that is Q, is equal to integral dq. So where to where? From 0 to r. These are the limits. So let us substitute the values. This rho a, rho r is given as a by r square e power minus 2r by a into 4 pi r square into dr. Here integration will be there. Here r square cancels, 4 pi and a are constants, so I will write outside. So it becomes integral 0 to r, outside 4 pi capital A comes out. This is capital Q. So what remain here? E power minus 2 small r by a into dr. This we have to integrate. Let us integrate it. 4 pi a. So on integrating, what we got? E power minus 2r by a by here minus 2 by a. Lower limit 0, upper limit is r. Now this is Q is equal to, that implies, so here it is 4 pi a, this I will take common, so minus a by 2 it comes, and this is e power minus 2r by a, lower limit is 0, upper limit is r. Here it goes 2 1s, 2 2s. So that implies Q is equal to 2 pi capital A small a, minus will be there here, and first upper limit we substitute, e power minus 2r by a, lower limit e power 0 1. So this is the integration. Now we have to calculate the r value. So r value we have to calculate. This I will send to this side. So this minus I will send to inside. I will send this minus inside. So 2 pi a 1 minus e power minus 2r by a. Now that implies 1 minus e power minus 2r by a is equal to q by 2 pi capital A small a. From it, e power 2r by a is equal to, what happens, it is 1 by 1 minus q by 2 pi a and small a. From this we have to calculate the r value. So by the definition of logarithm we can write like this: log this 1 by 1 minus q by 2 pi a small a is equal to e power 2r by a. Sorry, e will not be there here. We have taken log 2r by a. R value we have to calculate. That implies r is equal to, this 2 by a goes this side, that becomes a by 2 log, this is natural log, 1 by 1 minus q by 2 pi a and small a. So this is the value of r. So let us see which option is correct. So here our answer is a by 2 log 1 by 1 minus q 2 pi small a capital A. So fourth option is the correct option. It is a very good problem. You practice once again. In this problem, 64 conducting drops, each of radius 0.02 meter and each carrying a charge of 5 microcoulomb are combined to form a biggest drop. The ratio of surface density of bigger drop to the smaller drop will be. So this is the problem. So when 64 drops are combined to get the big drop, what physical quantity is common in both the cases? The volume. Total volume of 64 conducting drops is equal to volume of big drop. Why? Because all these 64 spherical drops only coalesce to make a bigger one. So that's why the volume is constant. So that aspect we take. Total volume of 64 drops is equal to volume of big drop. So this is what happened. Why? Because all the smaller drops are joined to make a big drop. That's why the total volume of 64 drops is equal to the volume of big drop. So 64 into volume 4 by 3 pi. R is the radius of small drops and the volume of big drop is, the radius of a big drop radius is r cube. So this is the analogy. So 3 by 4 pi, 3 by 4 pi cancels. So if we take a cube root on both sides, then we get r is equal to 64 4 cube, right? 4r. So this is the capital R, radius of a big drop. And next, each drop is having a charge. So if we club 64 charge drops, so total charge must be on a big drop. So total charge on 64 drops is equal to charge on big drop, right? So total charge 64 q is equal to charge on big sphere. So these are the results we got from this data. So what we have to find? The ratio of surface density of bigger drop to smaller drop. So that we calculate. Surface charge density, sigma of B big by sigma of small drop. Big drop formula, charge per charge per area, 4 pi r cube into, so small charge surface charge density, it becomes reciprocal, 4 pi r square by small q. Here common things, 4 pi. Sigma formula is charge per area. So surface area of the spherical drop is 4 pi r square. That is equal to, let us substitute the values. Capital Q value is how much? 64Q by R. Capital R value is 4R. So R square is 4R square. So 16R square into R square by Q. Now the Q cancels, R cancels, 16 ones, 16 fours. So that is equal to 4 by 1. So ratio sigma big is to sigma small drop is equal to 4:1. This is the answer. Let us see the correct option. That is option B. In this problem, two identical conducting spheres with negligible volume have 2.1 nanocoulomb and minus 0.1 nanocoulomb charges respectively. They are brought into contact and then separated by the distance 0.5 meter. The electrostatic force acting between the spheres is dash into 10 power minus 9 Newton. 4 pi epsilon naught is 1 by 9 into 10 to the power of 9. So, when the conducting spheres brought into contact then the charge on both of them is right. So the charge on both of them, Q1 is equal to Q2 is equal to Q is equal to Q1 plus Q2 by 2. This is the formula. What is Q1? 2.1 minus 0.1 by 2. That is 1 nanocoulomb. Now, distance of separation is 0.5 meter. That is equal to half meter. The force we have to calculate. That's all. F is equal to K Q square by R square. K value 9 into 10 to the power of 9. Q square nano is 10 power minus 9. So 10 power minus 18 by R square 1 by 4 square. So that is a thing. So this is 9 4s are 36. This 10 to the power of 9 minus 9 comes 10 to the power of minus 9 Newton. So this is our answer. So here the correct answer in the fill in the blank is 36. So that is the answer for this question. In this problem, two identical charged particles each having mass 10 gram and charge 2 into 10 to the power of minus 7 coulomb are placed on a horizontal table with a separation of L between them such that they stay in limiting equilibrium. If the coefficient of friction between each particle and the table is 0.25, find the value of L. See, let us imagine a table here. This is tabletop. Two particles are there. This is one particle, this is another particle. The distance between them is L. Now both are having charge, similar charge. This is also Q, this is also, let me say this is also plus Q and this is minus, this is also plus Q. Because the like charges are there, they repel each other with Coulombian force F. This force, this charge will repel this charge in this direction, and this charge, the second charge will repel the charge in this direction. That is the force acting, and these particles are having mass m. So this is the direction of weight acting on those particles, and then this is the normal reaction, and this is the direction of the friction works between the surface of the table and the sphere, the particle, wherever they came into contact, at that point in this direction the frictional force acts. So if these are the forces acting on the each particle here at limiting equilibrium, force, the Coulombian force is equal to the frictional force, then the body will be, these two particles will be in equilibrium. So formula for F is K Q square by L square is equal to frictional force mu mg. See here, m is given 10 gram, that is 10 into 10 power minus 3, that is equal to 10 power minus 2 kg, and charge on each of the particle given 2 into 10 to the power of minus 7 Coulomb. Acceleration due to gravity also given 10 meter per second square. This is the data given. So let us substitute the values. Mu also given. See, mu is equal to 0.25, that means 1 by 4. So this is the data. Let us substitute the values. So K is 9 into 10 to the power of 9. Q value is 2 into 10 power minus 7. Q square is there. So 4 into 10 power minus 14 by L square is equal to mu is equal to 1 by 4. M is equal to 10 power minus 2 into acceleration due to gravity 10. This 10 and this minus 2 goes, the minus 1 will be there. So I will cancel here. 10 to the power of minus 1 is there. Here minus 1 goes, minus 13. Then this 9 will go and this is minus 4. Now I will cross multiply. L square is equal to, see, by cross multiplying 9 into 4 into 4 into 10 power minus 4. So that is equal to now L. Therefore L is equal to 3 into 2 into 2 into 10 power minus 2. That is equal to 3 2s are 6, 6 2s are 12 into 10 power minus 2 meter. That is 12 centimeter. So that is the answer. Let us see which option is the correct one. So first option is the correct option. In this problem, 3 point charges of magnitude 5 microcoulomb, 0.16 microcoulomb and 0.3 microcoulomb are located at the vertices ABC of right angle triangle, whose sides are AB is equal to 3 cm, B is equal to 3 root 2 cm and CA 3 cm. And point A is the right angle corner. Charge at point A experiences dash newtons of electrostatic force due to the other two charges. So there is a right angle triangle here. So this is the hypotenuse. So this is obviously 3 centimeter. This is 3 centimeter. And this is 3 root 2 centimeter hypotenuse. So at A 90 degrees is there. This is A, B, C, like that. At A 5 microcoulomb is there. I'll take all positive. B 0.16 microcoulomb and at C 0.3 microcoulomb. So this 0.16 microcoulomb will repel this 5 microcoulomb in this direction. This I take F1 and this one will repel this charge in this direction. This is F2. So let us calculate F1 and F2. F1 formula K Q1 Q2 by R square. So K is 9 into 10 to the power of 9. Here F1 is this one, the force between 5 and 0.16. So 5 into 0.16 into 10 to the power of micro, so 10 power minus 12 by R square. R square is 3 centimeters, so that is 10 to the power of minus 4. So in 12, if 4 is taken out, this is 10 to the power of minus 8. This 10 will be there here, and this is 9 goes. So this is 0.80516 into here 110 is there. So this is 8 Newton, F1. Then F2 we calculate, same formula, 9 into 10 to the power of 9, and this force is between 0.3 and 5. So 5 microcoulomb, 0.3 microcoulomb, micro into micro, 10 power minus 12 by the square of the distance, 9 into 10 to the power of minus 4. So this is minus 8 here, and 9 will go, and this 10 will be there here. So 15 Newton. This is F2. So here F1, F2 are both are at 90 degrees. So resultant force is equal to root of F1 square plus F2 square, that is 8 square plus 15 square. So that is obviously 17 Newton. So 17 Newton is the answer. 17 Newton is the answer. In this problem, two equal positive point charges are separated by a distance 2a. The distance of point from the center of the line joining two charges on the equatorial line, perpendicular bisector, at which force experienced by a test charge Q0 becomes maximum at F by root x. The value of x is. So it is very simple. There are two charges. One is plus q, another is plus q. This is the perpendicular bisector. I may say here charge is there present at A, at B, and this is the center. Their charge Q0 is there at some distance. Q0 is there. So this is also positive. So here this positive will repel this positive in this direction, and this is F, and this also repel this one in this direction. The distance between A and B is 2a given. So this is A, and this is A, and this is some distance R, right? Then we know the formula for the force here. The resultant force is equal to K Q0 R by A square plus R square whole power 3 by 2. This is the formula we have got. So for maximum force, what is the condition for maximum force? dF by dx must is equal to 0. Let us differentiate this equation. So this is just like U by V. So the formula is here, d by dx of U by V. Formula V into du by dx minus U into dV by dx by V square. This is the formula. This formula I am using here. So df by dx. Here distance r we have taken, so I will take df by dr is equal to 0. So df by dr, this is first one is a square plus r square whole power 3 by 2 into, here only one r is there, minus this one r into, this is 3 by 2 a square plus r square 3 by 2 minus 1 into 2r by, this is a square plus r square whole power 3 by 2 whole square, and common will be there, that is k q q naught. So we have differentiated k q q naught came common, right? So that is equal to 0. So that implies, so that is equal to 0. So this will go that side and become 0. Then this is a square plus r square whole power 3 by 2 minus r 2r into r 2r square into 3 by 2 a square plus r square 3 by 2 minus 1 is 1 by 2, and kq naught also becomes 0, so that is equal to 0. That is the thing. So that implies a square plus r square, I will write like this, a square plus r square whole power 1 by 2 is equal to, this minus 2r goes this side, 2r square 3 by 2 a square plus r square whole power 1 by 2. So here 2 will cancel and this will cancel each other. So I left with a square plus r square is equal to 3r square, right? That implies a square is equal to, r square goes this side, so 2r square. That implies r is equal to a by root 2. So this is the answer. In the place of x, 2 is there. See here, a by root x, in the place of x root 2 is there. So here in the place of x 2 came, so answer is 2. In this problem, as shown in the figure, a configuration of two equal point charges Q naught is equal to plus 2 microcoulomb is placed on an inclined plane. Mass of each point charge is 20 gram. Assume that there is no friction between charges and plane. For the system of 2 point charges to be in equilibrium, the height h is equal to x into 10 to the power of minus 3 meter. The value of x is dash. So 4 pi epsilon naught value is also given, 1 by 9 into 10 to the power of 9 Newton meter square per Coulomb square, and g is equal to 10 meter per second square also given. It was given in 2023. Let us solve the problem. See, 2 point charges are there here. So here 1 point charge is there, Q naught. The value is plus 2 microcoulomb. Here is another charge, Q naught is equal to plus 2 microcoulomb, and these are the positions. So what are the forces acting here? The distance between them is not given, so let me take it as the distance between them is some L. Okay, so here the weight of a particle vertically acts downwards, and this is the direction of normal reaction force, and this is mg cos theta. So this is the theta value. So this also becomes theta. Then in downward direction, this is mg sin theta. These two are like charges, they repel each other. So this is the direction of Coulombian repulsive force acting on this Q naught, and this Q naught simultaneously also repel this Q naught in opposite direction. These are the forces acting on them. So in equilibrium it is clear that upward force is equal to downward force. So at equilibrium, upward force is equal to downward force. So here upward force is F and downward force is mg sin theta. These are the things. So let us substitute the value here. F formula we know, K Q1 Q2 by R square. So K value is 9 into 10 to the power of 9 into, here both charges are equal, 2 into 10 to the power of minus 6, that is micro. So squaring, so it is 4 into 10 to the power of minus 12 by the distance is L square not known, that is equal to mg sin theta. M is equal to 20 grams given. So 20 into 10 power minus 3 kg into 10 meter per second square into sin 30 is equal, sin theta is equal to 30 degrees given. This L value we have to determine. For this I can take this one, a right angle triangle. Here this is 30 degrees and this is H and this is L. This is Q naught position, this is another Q naught position. So to know the H, see H is opposite direction, so sin theta I will take. Sin 30 degrees is equal to opposite side by hypotenuse. So that from that H is equal, this H by sin theta, the 2H will come, that is L. So L is equal to 2H comes. So L value I will substitute here. So what are the things cancel? Let us write another step. 9 into 10 to the power of 9, 4 into 10 to the power of minus 12 by, here it comes L square. L square is equal to 4H square comes, that is equal to 20 into 10 power minus 3 into 10 sin 30 is equal to 1 by 2. So what are the common things here? 2 cancels. So this 10 goes, this is 10 power minus 1, 10 power minus 1 goes, 10 power minus 11 and 9 it goes, it is minus 2 and here 4 and 4 goes. So finally what we left with, this H square is equal to 9 into 10 to the power of minus 2 meter. So H is equal to 3 into 10 to the power of minus 1 meter, that is equal to 300 into 10 power minus 3 meter. So why? Because in the problem they have given in that way. See, let us go back and revisit the problem given. Here H is equal to x into 10 to the power of minus 3 he told. That's why here also we have taken in the form only 300 into 10 power minus 3 meter. So in the place of x 300 is there. So our answer is for this problem. So this is the problem, right? So in the place of x 300 is there. So 300 is the answer. In this problem, 3 point charges q minus 2q and plus 2q are placed on x-axis at a distance x is equal to 0, x is equal to 3 by 4r and x is equal to r respectively from origin as shown. If q is equal to 2 into 10 to the power of minus 6 coulomb and r is equal to 2 centimeter, the magnitude of the net force experienced by charge minus 2q is, see here we have to calculate the net force on minus 2q. So from x is equal to 0 to this one 3 by 4 r. So obviously this is 3/4 means this is 1/4. So here we have to calculate the force, net force on minus 2q. This plus 2q will attract minus 2q towards it. This let us name it as F1, and plus q will attract this minus q towards it. This is F2. Obviously this plus q is very far away from this one. F2 is weaker than F1. So from figure F2 is less than F1. Therefore net force we have to calculate. Net force is equal to F1 minus F2. That is equal to, what is F1? K Q 2Q into 2Q, 4Q square by the distance R square. So R square by 4 means it becomes 16, minus the force between these two, K 2Q into Q, 2Q square, into here 2Q square by distance 3 by 4 R square. So 9R square into 16. So these are the forces. So let us take what are the common K. This 16 K, right, and 2Q square also I can take common by R square. If I take common here, K to 16 went off, 2Q square went off, so 2 is there here, minus here all went off 1 by 9. So let us write the values here. 16 K value 9 into 10 to the power of 9, 2 into Q square. Q is 2 into 10 to the power of minus 6. Q square is 4 into 10 to the power of minus 12 by R value is 2 centimeter. So 2 centimeter square is 4 into 10 to the power of minus 4 meter square, into here 9 2s are 18 minus 1, 17 by 9. So what are the things cancel each other here? 4 into 10 to the power of minus 4 will go. 4 10 to the power of 12 is there. This is minus 8. So 9 and 9 cancels. 10 to the power of minus 8, and this one 10. 16 2s are 32 into 17 into 10, 544 0 Newton. So this is the net force acting on that minus 2q charge. So that is the answer. So here for this question, answer is 5440 Newton. In this problem, a point charge Q1 is equal to 4 Q0 is placed at origin. Another point charge Q2 minus Q0 is placed at x is equal to 12 centimeter. Charge of proton is Q0. The proton is placed on x-axis so that the electrostatic force on the proton is 0. In this situation, the position of proton from the origin is, so here this is the origin. At origin, Q1 is equal to Q1 is equal to 4 Q naught is placed. Here Q2 is equal to minus Q naught is placed, and at some distance, so here plus Q naught is there, minus Q naught there. So whenever we place this, you have to remember always, whenever you place a positive value between 1 minus and 1 plus, unlike charges are there, if you put any positive charge in between them, it will be repelled out and it will stay near to a smaller charge at x distance. This distance is given as 12 meter. So the null point always exists outside the two charge system if charges are not like charges, unlike charges, and this positive charge always be near to a smaller charge. So outside at x distance it will stay, so that the net force on Q naught is equal to 0. Let us calculate the x. X is equal to R by root of Q2 must be big one, Q1 must be small one. So null point from small charge. Null point from smaller charge. This formula is this one. Here plus and minus, which will come if the charges are unlike, this is minus 1. So let us calculate. R is equal to 12 meter by root of bigger charge 4 Q naught by smaller charge Q naught minus 1. So that is equal to 12 by Q naught cancels, root 4 is equal to 2 minus 1, that is equal to 12 meters. So this is 12 centimeters they have given. 12 centimeter. This is 12 centimeter. So 12 centimeter came. So what is the position of the proton from origin, they asked. Therefore the position of proton from the origin is equal to R plus X from the origin. So R is 12 centimeter given, X came as 12 centimeter, so total 24 centimeter. So that is the answer for this particular question. So answer is 24 centimeter. Like this we have to do this problem. In this problem, two identical tennis balls each have mass m and charge q are suspended from a fixed point by threads of length L. What is the equilibrium separation when each thread makes a small angle theta with the vertical? So this is equilibrium problem. So this is a common, I will name it as a O. Two pendulum are hanged, suspended, and the distance between them x we have to find, and with the vertical, this is the vertical, it is making angle theta, length of the pendulum is L. The forces acting on this bob is the Coulombian repulsive force. Why? Because both are having same charge, like charge, and it is having mass m, so weight is also acting downwards. So these are the forces acting. What we know from this diagram, when this is a case of equilibrium, we know tan theta is equal to F by mg. But one thing you remember, tan theta is opposite side by adjacent side. Adjacent side length we don't know. This is a perpendicular bisector. So this I will give some names: A, B, C. CB is equal to x by 2. This we know because total length is separation is x. So opposite side we know. So whenever theta is very small, we can also approximate this into sine theta. So what we have to remember, when theta is very much less, tan theta, sine theta, these are all equal to theta. So any relation we can take as per our needs in the problem. So F by mg is equal to sine theta. F by mg, F is equal to, see what is the F value here? K means 1 by 4 pi epsilon naught K Q into Q square by distance square x square. Here mg will be there only here, is equal to sine theta opposite side by hypotenuse. So these are the values. So substituting is over. So x value we have to calculate. So we'll cross multiply here. Then what we get, x cube is equal to 2 ones, 2 twos. So this is q square L by 2 pi epsilon naught mg. This is the remaining thing. So x we have to find. X is equal to q square L by 2 pi epsilon naught mg whole power 1 by 3. So this is the answer. So in this particular problem, the second option B is the correct option. In this problem, 3 pendulum were there. Because of all are having same quantity of charge on them, each charge is plus 2c. So here plus 2 Coulomb charge is there. On this bob also, these are the bobs. So this is the pendulum, plus 2c is there. And this pendulum also plus 2c charge is there. All pendulum are tied to same fixed point. Because of the repulsion, they repelled and they went off from each other. So here on the ground, they are making a equilateral triangle, 1 meter, 1 meter, 1 meter. So this triangle only we have to take. Okay. So let us, because this 1 meter, 1 meter, 1 meter, this is the separation. So I will draw a diagram like this. All are 1 meters only. So this is 1 meter, this is 1 meter, this is 1 meter. Here the charge is plus 2c, this is also plus 2 Coulomb, and this is also plus 2 Coulomb. Now what we have to find, they form an equilateral triangle of side 1 meter. See, once again let us go through this diagram. 3 identical charged balls, each of charge 2c, 2 Coulomb, are suspended from a common point P by silk threads of 2 meter each. They form an equilateral triangle of side 1 meter. The ratio of net force on charged ball to force between any two charged balls. So net force will calculate here. So these are all like charges. This charge will repel in this direction with force F because distance is same, and 2 two charges also same. Here also same, distance is same and quantity of charge is also same. So they will repel with the same force here. So it is an equilateral triangle. So this angle is equal to 60 degrees. So what we know in vectors lesson, if theta is equal to 60 degrees and F1 is equal to F2 is equal to F, the net force, the resultant force formula is root 3F. The net force on a charged ball is equal to root 3F. Like that we write. Now force between any two charged bodies we have to take. Force between any two charged balls is equal to, see, any two. If we take these two plus 2 plus 2 same 1 meter distance, so this is the force acting on each one, right? So this is also F. Why? The quantity of charges are same, distance is same. Quantity are same, distance is same. So here we have taken F name. So here two charges are same value and they are like charges, they are repelling 1 meter. See here, if 2C is there and 1 meter is there, F name I have given. So here also same thing is there. So here also I can give a name for force F. So this is the force. So now what we have to calculate? This is first one, this is the second one. So in the problem they are asking the ratio of net force on a charged body by force between any two charged bodies. So 1 divided by 2 is equal to root 3F by F. So FF cancels, root 3 by 1. So our answer is root 3 is to 1. That is the answer. So which option is suitable for this one? Yeah, the fourth option D is the correct answer. In this problem, two electrons each are fixed at distance 2D. The third charged proton placed at the midpoint is displaced slightly by a distance x. X is very much less than D, perpendicular to the line joining the two fixed charges. Proton will execute simple harmonic motion having angular velocity dash. So what given in our problem is two electrons are there. So electron charge is minus q. This is another electron, that charge also minus q. So the separation between them is 2D. Exactly at the middle of these two charges, so that is at a d distance, a proton is placed. Proton is plus q. Charges, magnitude of charge is same, but the type of charge is different. Now we displaced this through x distance. Then what happened? This q is attracted by this small q in this direction, that is F, and this is also attract in this direction. So the charge will come back and it is executing SHM. The stable equilibrium of this proton lies along the line, along equatorial line. This line we call it as a equatorial line. So the diagram is like this. So this is x distance. Here plus q is there, here minus q is there, here minus q is there. So this plus q is attracted by this minus q electron, and this also attracted by this one. So these forces are equal, and the distance is d here. So this distance is root of d square plus x square. So now these two forces are acting here on this proton, so it will come back to this. This is the direction of net force. Therefore, the net force on proton, net force on proton, Fn is equal to, see F, this is let us take it as theta, right? So this is a cos theta minus, because it is downwards, 2F cos theta. So this is the net force. Let us substitute the values now. Net force is equal to minus 2F. F is K Q1 Q2 by R square. So K value is 1 by 4 pi epsilon naught Q1 Q2, both are Q's only, Q square, by the distance between them is root of d square plus x square into cos theta. Cos theta formula, adjacent side by hypotenuse. Adjacent side is x, right? X distance we have we displace it, so x by root of d square plus x square. Here this is whole square. 2 ones, 2 twos. So net force is equal to q square x by 2 pi epsilon naught d square plus x square whole power 3 by 2 is equal to net force. Here in the problem, mass of the proton is, charged particle is given as small m. So I will write like this. That implies, in the place of Fn, I will write m into A is equal to q square x by 2 pi epsilon naught d square plus x square whole power 3 by 2. Here one thing is there, the x is very much less than d, so we can neglect x square value, we can neglect. So if we neglect x square value, then what happens, it is A is equal to, this m I will send this side, q square x by 2 pi epsilon naught d square, 2 cancels, this becomes d cube, and this m comes here. So this is the equation 1. This equation is SHM equation. XHM equation A is equal to minus omega square x. So comparing, we'll compare both the equations, then omega square value will get, in the place of omega square we got q square by 2 pi epsilon naught d cube and m. That's why the angular frequency omega is equal to q square by 2 pi epsilon naught d cube m whole power 1 by 2. So this is our answer. So let us check which option is correct for this problem. Q square by 2 pi epsilon naught dm cubes. Yes, option B is the correct option. In this problem, two identical charged spheres are suspended by strings of equal lengths. The strings make an angle 30 degrees with each other. When suspended in a liquid of density 0.8 gram per centimeter cube, the angle remains the same. If density of the material of the sphere is 1.6 gram per centimeter cube, the dielectric constant of the liquid is. In concept videos, this concept is discussed thoroughly. So if you want to do step by step, it is little bit lengthy. But one thing you remember, when the angle is not changing when suspended in liquid, the shortcut formula for K is density of material of the solid by density of the solid minus density of the liquid. So if you can remember this shortcut, but here provided the angle should not change when we immerse in a liquid, then everything is correct. So this is the shortcut formula. So this solid sphere density is 1.6 by 1.6 minus 0.8. So we'll get 1.6 by 0.8. 8 ones, 8 twos are 16. So 2 is the answer. Like this, if you can remember, if you know the concept and remember the shortcut, within a fraction of time you can solve the problem. So here in this problem, option D is the correct option. In this problem, two small spheres each of mass 10 mg are suspended from a point by thread 0.5 meter long. They are equally charged and repel each other to a distance of 0.20 meter. The charge on each of the sphere is A by 21 into 10 to the power of minus 8 Coulomb. The value of A will be, so here first of all, here the units are, we have to change the units. Here we have to change the units. So let us write the data first. Mass of each bob is equal to 10 mg. That is equal to 10 into 10 to the power of minus 3 gram. That is equal to 10 into 10 power minus 3 into 10 power minus 3 kg. That is equal to, this one go 10 power minus 5 kg. And thread length is equal to 0.5 meter. And the distance between the bobs x is equal to 0.2 meter. So from same rigid support, two pendulum are there here, both are having same charge. So this is the separation between them. This is the perpendicular bisector, this is the angle theta. So this is total distance is 0.2 meter. So this is 0.1 meter. So this is also 0.1. So this is 0.5 meter. So this length is 0.24 because that is the hypotenuse. So we are having this diagram. This is 0.1, this is 0.5, this is 0.24, and this is the bob is there. This is the force acting, Coulombian force. This is mg. So from this what we can write, tan theta is equal to F by mg. This is the theta. So let us substitute the values now. Tan theta, opposite side by adjacent side. So 0.1 by root of 0.24 is equal to F 1 by 4 pi epsilon naught Q square by R square. R is equal to, the distance between them is 0.2. So 4 into 10 to the power of minus 2. This is square into mg. M is equal to 10 to the power of minus 5 into g is 10. So all the values we have substituted here. So we write like this: 0.1, that is 10 power minus 1 by this. I will write like this: root 24 into 10 to the power of minus 1, like that I can write, is equal to 9 into 10 to the power of 9 into q square by here 4 into 10, 10 is there here, this will go minus 1, 4 into 10 power minus 6, here these two also cancel. So finally what we get here, by cross multiplying, 9 into 10 to the power of 9 into q square into root 24 is equal to 4 into 10 power minus 6. So this I can write like this: q square is equal to 4 into 10 power minus 6 into 10 power minus 10 to power 9 goes that side, it becomes 10 power minus 9 by this is 9 into root 24 is 4.9. So now this 4.9 I can write like this: 4 into 10 to the power of minus 6, 10 to the power of minus 9, 10 to the power of minus 15 by 9 into 49 into 10 to the power of minus 1. So this is 10 to the power of minus 14. So finally q square is equal to, so everything we have to see, they must be in squares. So 4 by 9 into 49. Here 10 to the power of minus 14 is there. If it becomes 16, we can easy to make it square. So 10 to the power of minus 16 I will write. So here I will put 2 zeros. Why I have taken 10 to the power of minus 16 here? Because in the problem they have given 10 to the power of minus 8. So square of 10 to the power of minus 8 is 10 to the power of minus 16. That's why I made it to 10 to the power of minus 16. So from this q value easily I can get. Q is equal to, so 400 square root is 20, this is 3, this is 7 into 10 to the power of minus 8. So easily I got, this is so finally I got the value q is equal to 20 by 3 7s are 21 into 10 to the power of minus 8. So by comparing, this is in coulombs. Here let us go back to the problem. In this problem they have given that a by 21 into 10 to the power of minus 8. A value they have asked. Here we got a value as 20. See here a value is 20. A by 21 into 10 power minus 8. So in the place of a, 20 is there. So our answer is 20. So if for this problem answer is 20.